A multi-million-dollar stealth fighter flying over Eastern Europe is completely useless if it runs out of fuel. Imagine a state-of-the-art Royal Netherlands Air Force F-35 Lightning II suddenly flashing a low fuel warning while operating inside the engagement envelope of an active Russian S-400 surface-to-air missile system. This is the exact high-stakes crisis that modern air combat planners face. To maintain its radar-evading profile, the F-35 must store its entire combat payload and fuel internally. This strict engineering constraint limits its internal fuel capacity to exactly 8,390 kilograms, which restricts its combat radius to just 1,093 kilometers. If pilots attach external fuel tanks to extend their range, they instantly destroy their stealth profile, leaving them fully exposed and vulnerable to long-range radar tracking. On paper, their only tactical salvation would be a reliable, highly survivable aerial refueler. This is why leading global defense analysts argue that the ultimate power broker in European airspace is not the fighter itself, but the Netherlands-operated Airbus, A330 MRTT. Stationed at Eindhoven Air Base, this strategic asset solves the lethal paradox of stealth aviation by acting as an invisible shield for NATO frontline fighters. On March 26, 2026, the multinational MRTT fleet officially achieved full operating capability after welcoming its 10th aircraft. This milestone secures a permanent logistical lifeline that keeps NATO stealth fleets operational without relying on American tankers. Before we go on, you think stealth fighters can survive modern warfare without these giant flying gas stations? Subscribe now to stay updated on the latest global defense tech, and tell me where you are watching from. The true genius of the Netherlands-operated Airbus, A330 MRTT, lies in its transition from a conventional transport asset into a highly automated combat shield. At the center of this technological leap is the automatic air-to-air refueling system, known as A3R, which Airbus successfully certified for operational use in July 2022. This revolutionary system completely removes human error from the high-stress refueling process. Using an advanced suite of three-dimensional digital cameras and passive optoelectronic sensors mounted beneath the fuselage, the system automatically captures the structural geometry of the approaching F-35 Lightning II. The automated flying boom then calculates relative velocities and tracking vectors in real time, executing a flawless physical coupling without a single manual input from the operator. This system dramatically accelerates fuel transfer, pumping exactly 3,600 kilograms of aviation fuel per minute through its advanced boom system. Beyond this mechanical precision, the aircraft serves as an active electronic warfare node. When an F-35 approaches the tanker, the two platforms establish an isolated, high-security data bubble via encrypted Link 16 architecture. The recent full operating capability milestone achieved in March 2026 integrated advanced anti-jamming global positioning system receivers and upgraded missile approach warning systems across the entire fleet. As aggressive electronic warfare and GPS spoofing activities continue to surge across the Baltic region, this protective digital umbrella becomes paramount. The automated tanker continuously monitors the electromagnetic spectrum, absorbing and neutralizing hostile scanning frequencies. This vital intervention allows the refueling process to take place safely, shielding the stealth fighters at their moment of maximum vulnerability. By deploying these combined capabilities, The strategic platform ensures that the primary stealth assets of the alliance remain fully fueled, completely connected, and tactically protected against long-range tracking networks. This automated shield transforms the Royal Netherlands Air Force Base at Eindhoven into the most critical power hub for European airspace logistics. The strategic value of this platform comes down to raw payload capacity and geographical coverage. Carrying a massive internal fuel capacity of 111 tons without requiring any additional fuel tanks in the cargo bay, a single Airbus A330 MRTT can sustain a long-range combat air patrol for a prolonged period. This massive reservoir allows the aircraft to remain on station for exactly 2 hours at a distance of 2,300 kilometers from its home base, while still holding 70 tons of fuel available for transfer. This means one tanker can single-handedly keep a formation of 4 F-35 Lightning II fighters continuously operational during extended deep strike or deterrence missions. By establishing this collective fleet, the Netherlands has successfully pioneered a revolutionary pooling and sharing model that reshapes regional defense. Following the integration of Sweden and Denmark into the alliance framework, the expanding fleet of 12 planned aircraft completely eliminates the European reliance on American KC-135 or KC-46 tankers. This operational self-sufficiency allows the United States military to redirect its own critical refueling assets to the Indo-Pacific Command Theater, enhancing deterrence postures globally. Furthermore, because partner nations like Australia operate the identical KC-30A platform, this total technical standardization ensures that the Netherlands-led fleet can seamlessly integrate into large-scale global exercises. The ability to offload tons of fuel while simultaneously transporting 45 tons of military cargo or 300 personnel makes this aircraft the ultimate logistical backbone, allowing NATO to project continuous air power across the eastern flank and beyond. Despite the undeniable strategic advantage of this logistical backbone, the deployment of this automated shield introduces a critical tactical vulnerability that few military analysts openly discuss. The lethal paradox of modern air combat is that stealth fighters rely entirely on electronic silence to survive, yet the process of mid-air refueling forces an operational compromise. When the massive Airbus A330 MRTT activates its dual-band weather radars, its military transponders, and the encrypted Link 16 data links required to sync with an approaching F-35 Lightning II, it generates a massive electromagnetic signature. On the passive long-range radar systems operated by adversaries, this localized energy spike acts like an electromagnetic beacon in a dark sky. The tanker successfully shields the fighter from immediate physical intercept using advanced electronic countermeasures. But the massive radar cross-section of the commercial derivative frame inherently compromises the exact coordinates of the stealth fleet during the coupling process. Additionally, because the fleet relies heavily on commercial aircraft supply chains for its ongoing maintenance, unexpected global commercial disruptions could bottleneck spare part availability for the fleet at Eindhoven Air Base. The ultimate strategic takeaway is clear. Modern air warfare is no longer defined solely by the speed or stealth of front-line strike fighters, but by the resilience and survivability of the logistical umbilical cord that keeps them airborne. As the fleet hits full operating capability in 2026, it secures the European sky, but remains the primary high-value target for any near-peer adversary. In a total peer conflict, The side that manages to sever the refueling chain wins the war, making this platform both the greatest strength and the most sensitive bottleneck of the alliance. With long-range hypersonic threats advancing rapidly, will these massive flying gas stations remain viable in a high-intensity conflict, or will they become the ultimate Achilles heel for stealth aviation?